So this will be due tomorrow. What you need? Yeah. This will be due tomorrow. And if you have already started some problems and you want to check your answer, I'm pretty much only going to go like 2 or 3 from each section. Probably either if it's a table, I'll probably stay on the left side, or maybe the evens. It just all depends on how it maps out. But yes, your test is tomorrow. Okay. The first section, you will have some proportion questions. Our percentage was high when we assessed this, when we were in Ms. Griffin's room. You need to cross multiply. If you need to show your little butterfly method, you can. But what I'm going to check for is the cross products. So what I should see is when I cross multiply 2 times the expression x plus 8, that needs to be 2 parentheses x plus 8, and then equals 36. Now, if you want to switch it around, that's fine, but those are the 2 things I first should be able to see on your paper. Then you would need to distribute the 2, which would result in 2x plus 16 equals 36. And then now we're back to a 2-step equation, solving for x. Subtract your 16. We get 2x equals 20. And then you should get x equals 10. Do we have questions about solving proportions? Okay. Now you will have some with 2 cross products, 2 expressions. So like if I jump to number 3, this should be 3 parentheses y minus 7 equals 5 parentheses y minus 5. Don't forget your sign. Don't make sign errors. We need to distribute on both sides. Yes, Cameron?
We just like do it swap, like 5, like do the 5 on the left and 3 on the right, I guess.
Yeah, this is fine. If you have it this way, this is fine as well. You can switch your cross products around. That's fine. When you distribute, you're going to end up with 3y minus 21 equals 5y minus 25. Now you got variables on both sides, so you should be starting with the smallest variable, which is our 3y. So when I do the inverse of that by subtracting, I have a negative 21 equals 2y minus 35. And then you would need it to add 35 on both sides to cancel out the constant. That's a 3, sorry.
Why is it 35?
I'm sorry, 25. Why did I change that? So that gives me 4, equals 2y, and y equals 2. So you're going to have the first set is proportions. Then we're going to go straight into evaluating functions. I'm going to highlight this. You need to remember that f of a negative 3 means the negative 3 is your input and you plug it in for x. So you need to remember, oh, that's dark, sorry, let me go yellow. You need to remember that what's inside the parentheses represents the x. Now that is different compared to when f of x equals a negative 3. That means your whole function is equal to a negative 3, and you have to plug it in to y. The thing you have to remember, and you might want to add this to your packet, is your f of x is the same as y. So your f of x equals y. All right, so literally all we're doing for each function, this is g sub x, f of x, h of x, is, and I'm just kind of trying to give you a little example, is wherever the x is, we're going to use parentheses and plug in a value in for that. Okay, here this would be parentheses squared plus 7. Here this would be 12 over parentheses, then 2 parentheses plus 9, because we have to plug in the value for x that they give us. All right, so in number 5, g sub 10, what does the 10 represent? What does this represent? Yeah, it represents the x. So this should be negative 3 parentheses 10 plus 1. So you get a negative 30 plus 1, which your answer should be negative 29. Now, we can write this as an ordered pair. This would be 10, comma, negative 29. Now they were asking for f of x, so now I have to use this expression. Make sure you're following your order of operations. So this would be parentheses 3 squared plus 7. You need to do your exponent first. So that gives you 9. Then add the 7. We get 16. The order pair would be 3, comma, 16. Now, that doesn't change if your input, the value inside the parentheses, is a variable. So I'm going to jump to number 9, h of a. This a is your x. The function h of x, that function had the expression 12 over x. So we're just going to now substitute the a for x. So this is just going to be 12 over a. And that's your final answer. But on 6, now we have an expression here. This b plus c is your x. Is what we're going to input into the g sub function, which is a negative 3 parentheses plus 1. I'm now going to plug inside the parentheses b plus c. So you have to distribute and simplify. This becomes a negative 3b minus 3c plus 1. And that is the final answer. Those are not like terms, so you cannot combine them. Yes. All right, so then you have to read off of tables with functions. So if we go to 11 through 17, remember your x represents your input, and your f of x, which is the same thing as y, is your output. So nothing is changing. If I'm looking for the value on the table in the function f of negative 3, that negative 3 still represents the x. So I have to look on this first row to find where x is a negative 3, and we should just get 2. Because right here, there's a negative 3 maps to 2. So all we're doing. Now, I'm going to jump to 14. What will we have to write for f of a negative 1? Because this negative 1 represents x. And is there a negative 1 in the x row? No. So, to get the value off the table, since we do not have a -1 on the x row, you write unknown. If you cannot find the value off the table, it is unknown. Now, this next row, they're saying if f of x equals 9, what is x? Now, this value equals 9 represents the output. So now I'm looking at the second row for the 9. Here it is right here. So that means the x would equal 2, because they want to know what is the x. All right, so in 16, what would be our answer for f of 4? Because we're looking for an output of 4. X equals 8. Or we got two answers here, because 4 is repeated there. So you have to put x equals 8 or x equals 9. You have to show both answers from the table. Guys, do we have questions on evaluating functions from a table? This section? All right, so then you're going to have to find the x when given the function. For section 4, you have to probably think of it as you're working backwards. Remember, this g sub x equals 16. This was, oh, I forgot my pen, sorry. This represents the output. So now I can take this output and plug it into this g sub x here. So I would set it up as 16 equals a -3x plus 1. And now you're just finding the x, solving for x. So this is a basic two-step equation. -1 to get rid of the constant. 15 equals -3x. Divide by that -3. So -5 equals the x. And that's what you're trying to find. So if h of x equals a -2, this -2 gets plugged back into h of x, and we're going to solve it for x. So -2 equals 12 over x. If you want, you can change this into a proportion and cross multiply, or you have to do the inverse. If I cross multiply here, I get -2x equals 12, and now I can solve for x. So how would you set up number 20? Did-
23 equals x squared plus 7.
23 equals x squared plus 7. Yep. You still need to isolate this x squared. So that requires subtracting 7. This will leave you with 16 equals x squared. And then, because we have an exponent of 2, take the inverse of that, you take the square root. This has two answers, guys. Do you know what the value of x is going to be? X is going to be 4, and yes, -4. Or you can write it as x equals plus or minus 4. Positive and -4. That's a symbol to show a positive and a negative answer in one. Plus minus. All right, the next section, this is where you can use your graphing calculator to help you. Remember, our X is our input values, and the Y is our output. So we're looking at this function. This Y is the same thing as f of X. So I could just work it out and plug in my 0 for my X here. Well, anything times 0 is 0. So this first one is 5. Here I'm doing -2 times 1 plus 5. This would give me a -2 plus 5. Will leave me with 3. Or you can go to your calculator. So this is what I was going to let you do. Who remembers how to build a table, or let the calculator find the output for you? Oscar.
Type in the equation.
Type in the equation of y equals. So the y equal button up here in the upper left hand corner. There it is. We're going to type in the -2x plus 5. This is a way to check your work if you've already did this. -2. Who remembers where the X button is? Yes.
Alpha.
Right next to alpha. There we go. 2x plus 5. We enter it in. Now how do we get to the table? Second graph. And so I need to go down to where I see a 0, because that's where our table starts. It starts at 0. And then we can just input or plug in or answer or fill in our table. Now, let me go back to our here. So we should have 5, 3, and then a -1, and then -5. Then we're plotting these points on the X and Y coordinate plane. So 0, 5 is here on the Y axis. Then we have 1, 3. Then we had 3, -1. And then 5, -5. And then we can input a line through those points using your straight edge. Now, can I tell you how to do this on the test? No, so you have to remember the keystrokes. I cannot tell you what to punch to get to a table tomorrow. At this point, you have to know that, because you are not going to be told when you take STAR. All right, so if you start using your calculator to answer, I guess just to indicate that, you can just put C, so I know that you use your calculator to get to your answer. Now, the calculator will graph for you, but you need the actual points. If you wanted to see what the graph looks like, you just have to hit the graph button, and you can see what the line looks like and see if it matches what you graphed. Okay? All right. So when you get to 24, they want you to find the range of the function y equals 3 fourths x plus 17 when the domain is a -12, -4, and 8. What does your domain represent? The x. So all I want you to do here is you create the table. In the x column, you're putting -12, -4, and 8, and then you are telling me the value that would exist in the table for y. So yes, you can use your calculator. When you get a new equation or function, you need to clear out the old one. To put it in as a fraction, you need to have alpha y equals. Enter, you get your fraction box. 3 goes on top, 4 goes on the bottom, and then you have to remember to arrow to the right to get your variable. So we can plug in the x, and then plus 17 and hit enter and go second graph. Now we're trying to find the values at a negative 12. Right now my table is at a negative 4. So I would have to scroll up to find that negative 12 to see what the output is. It is 8. And then I can get that negative 4 we already had. It was 14. And then the last one we need was 8. So we need to scroll down and find 8. And it was 23. You have any questions there? All right. So I'm also going to ask you to find values using function implication with a graph. So remember, what's inside of this parentheses here represents your x. So that means we need to go on our x-axis right here, the horizontal, find this negative 2, and then find the point on the function, on the graph. That point right there is negative 2, 4. So the output is the value 4. So if I give you the x, you have to give me the y as an order pair. So if I'm looking at a negative 1, negative 1 is here. I go up, there's my point. That is in between 4 and 3. So that point here would be 3.5. At f of 0, 0 is here where the axes intersect. I go up, find that point. That is 0, 3. So this equals 3. And then when find the value of f of 2. This is 1, this is 2. Right here on the x-axis, I gotta go and see the point on the graph. That point is 2, negative 1. So that means f of 2 equals negative 1. Do we have questions on how to read the output or to read function notations with graphs? All right, so then from there, we're going to get into relations, functions, domains versus range. This is what we just ended with our homework 1. I am going to ask you to do it with inequality notation. Hopefully you noticed on that ELC question that you did yesterday, that's the notation they use. Okay, so that means we have to use our less than, our greater than, our less than or equal to, greater than or equal to. So if I'm doing my domain, domain represents the x values. This is when I scan left to right. So I think what I was noticing is your graph, if I was to trace the graph, this is the graph, this little upside down V. So I'm just tracing the graph. So if I was tracing it going all the way to the left of the graph, that means I'm right here. Okay, and I see an arrow, which means that tells me it's continuous, it keeps going. But your domain is your x-axis. So when I look up, I see that arrow is pointing to the left. So that indicates negative infinity. If I scan the graph all the way, trace it till I get to the right of the graph, again, there's an arrow here. But if I look up at the x-axis, this arrow is pointing to the right. So that's positive infinity. So my domain here, which represents the x values, would be a negative infinity. If I do it as an inequality, is less than x, which is less than infinity. But what do we write whenever we have from a negative infinity to positive infinity? Yeah, so this answer is all real numbers. That symbol right there. Now, the range, this is when we're looking at the y values, is from your bottom of the graph to the top of your graph. Okay? Well, if I'm scanning, the bottom of my graph is here. And it is pointing down. And if it's pointing down, and it's pointing down on both sides too, that means it's pointing to a negative infinity. So even if I look here on the y-axis, because the range is your y, this arrow is pointing down as well, so that is a negative infinity. Now I need to find the top of the graph. So if I'm scanning, tracing right here, this is the highest it gets. That is the top. I still need to find that value on the y-axis. That is at 0. So, and since it's a solid line right here, that means it's solid here at 0, and it's going everything down from 0. So, what would be the inequality for the range? If it's the highest is at 0, and then it keeps going down to a negative infinity. How would I show that as an inequality? This is our range. That's the line that represents the range. I'll highlight it. This is the one I'm focusing on right here. Are y'all with me on that? Do y'all, I know y'all struggle on this. How would you graph this? If the arrow's pointing right, what would you do? Greater than, okay. Our arrow is pointing down to a negative, so it should be pointing to the left, right? So what would that be? And where is it starting at? Where does this point start at right here? I'm sorry. I know I don't have a number on here, but you should be able to correlate where this point starts. 0. So what's the inequality for the range? Okay, I'm gonna put 0 here. How would I show this inequality? It would be less than. So what am I writing? Come on, I'm waiting for an answer. What am I gonna write? Say that again. Not negative infinity. I don't use negative infinity. And y is less than or equal to 0. Because I don't think we've ever used on a number line when you graphed and it was closed and pointing this way, or when it was open and pointing that way, we never used an infinity in the inequality. We used the start point or bound, and we just use less than or greater than, because it's going to keep going on forever. Now, if I make these two graphs overlap, something like this, are y'all with me so far? And I'm now just looking at the overlap. So that means it's not going to go forever, and it's not going to go forever. Now we have another restriction. So it's different in that context. But if I just have a simple arrow pointing to the left or to the right, the thing is, y'all not associating this as a number line. The y-axis is a number line too. All I'm doing is rotating it horizontal. All I'm doing is taking this number line that's on the y-axis and now just rotating it so I look at it this way or that way, you know, like I did before. All right, would this be a function? Yes or no?
Yes.
Yeah, this is a function. Now this one's different. This is a mapping, so you should be using braces here because this is continuous. What are the domain? What's the domain on 30? Yeah, 0, 4, 9. We're done. 0, 4, 9. 0, comma 4, comma 9. What is the range? We should be using braces as well. 2, 3, 4, 5. Is this a function?
No.
No, it is not. Why not? Yeah, you have 9, 4 right here, and 9, 5. The 9 repeats. So this is kind of similar to what you have to do on homework. We'll go to the next page. What number do you need me to go over?
Number.
Which statement is true? So, is only graph A a function? How do I determine if it's a function?
By drawing the thingy.
What's a thingy? I don't know what a thingy is. Okay, draw a line straight up and down. Okay, so I draw a line up and down. Would this be a function? No, it is not. No. Right here, intersects 3 different spots. All right. The function of graph B is this, not that line, sorry. It's this horizontal line right here. So would that line be a function? That is a no again. It's gonna touch everywhere. If I drew a line there, it touches everywhere. So the answer was what? D. Yes, very good. D. Thank you. 36. I'm going to 36. All right, so I'm going to scan the graph left to right. This is the left of my graph. But where do I look for the domain? Where do I look for the domain on graphs? Yeah, but after I go here, where do I get to my answer? That's what I'm talking about. Michael, I'm saying I am at far left, but where is my answer? Yes, it is here. All right, so we go left. Here's the far right. What is the answer for the domain here? It is the 2. All right, so this domain as an inequality is a -2 is less than x. I don't use equal to because it's open right here. And it's less than +2. To do the range, this is when I'm going to look at the bottom of the graph. The lowest it gets is here, but I have to look at the y-axis. That's at a -4. The highest the graph gets is here. This is the top of the graph. And I still have to look at the y-axis. That is 0. Your range is in between these sets of numbers. So that would mean I'm a -4 is less than or equal to. I put equal to because it was solid right here at this hump, at this curve. Less than or equal to y, which is less than or equal to 0. Is this a function? Yes, it is a function. Okay, so once you start getting 37 and on, well, 39 is open-ended, but 37, 38, you see how you got multiple choice questions, and then on the back, some more sample EOC questions. This is what you have to be able to answer for domain and range. Okay. Okay, so I want to talk about, look at real quick 40, because I saw a couple of these mistakes, and to me it was a poor test taking strategy. On your EOC questions, I checked it yesterday. The minute I read, it says which of these best represents the domain. If you know your vocabulary and you know domain represents X, okay, then we should never be picking something that says a Y. That needs to be eliminated. Y or f of X should not be picking. So that means we should be focusing on the x-axis. So if this is the left of it, and because we see it's pointing up, right? And if I look at the x-axis, it's going to keep going. Wouldn't this be a negative infinity over here? Right? And if this is the right of the graph, it is pointing up, so it keeps going. Wouldn't that be a positive infinity? And what happens whenever I have a negative to a positive infinity? All real numbers. We are done. Alright, so guys, packet is due tomorrow. If you have it done right now, just show it to me real quick so I can stamp it.